Dear friends, good morning. Today we are going to discuss about gears. So myself, Kadir, Assistant Professor, Department of Aeronautical Engineering, Hindustan College of Engineering and Technology, Coimbatore. Gears are toothed wheels used for transmitting motion and power from one shaft to another shaft when they are not too far apart and when a constant velocity ratio is desired. The power transmission is the movement of energy from one place of generation to a location where it is applied to performing useful work. In addition to that, transmitting the motion, the gears often used to vary the speed or to change the direction of motion from one shaft to another shaft. When it is compared with belt and chain drives, gear drives are more compact, can operate at high speeds, and can be used to where precise timing is required. Also, the gears are used when large power is to be transmitted. Quite normally, comparing with this belt drive and the chain drive, the power loss during the transmission is much lower in this gear drives. So a gear is a component within a transmission device that transmit rotational force to another gear or device. The frictional wheels or discs and cylinders are used in early days to transmit power from one shaft to another. The power which can be transmitted by frictional wheels is depends on the friction between the contact surfaces. Due to the slippage between these contact wheels, this cannot be used for transmitting higher powers. The frictional wheels are non-positive drives. To overcome this problem, teeth are cut on the contacting wheels. With the wheels on the contacting surface, the frictional wheels are called as gears. So the gear drive is called positive drive because there is no slip between them. In any pair of gears, the smaller one is called pinion and the larger one is called gear or wheel or pull gear, irrespective of which is driving the other. When pinion is the driver, it results in step down drive in which the output speed decreases and the torque increases. On the other hand, when the gear is the driver, the results in step up drive in which the output speed increases and the torque decreases. Since there is no slip, so exact velocity ratio can be obtained in these gear drives. These gear drives are capable of transmitting larger power than that of belt and chain drives. So it is more efficient and effective and it requires a less space when compared with belt and rope drives and hence it is more compact. Classification of gears. So gears can be classified into majorly 5 types. First one based on the relative position of their shaft axis. Second one based on the relative motion of the shafts. Third one based on the peripheral speed. Fourth one based on the position of teeth on the wheels. And last one based on the type of gearing. So according to that relative position of the shaft, the gears can be classified into 3 types. One is parallel shafts, intersecting shafts, non-parallel, non-intersecting shafts. So 3 categories. And according to the relative motion, the gears classified into 3 types. One is row gears, planetary gears, differential gears. According to the peripheral speed, again the gears can be classified into three types. One is low speed gear, medium speed gear, high speed gear. So according to the position of the teeth on the wheels, the gears are classified into four types. One is straight gears, helical gears, herringbone gears, curved teeth gears. And based on the type of gearing, that is external gearing, internal gearing, and the rack and pinion gear. Again, the parallel axis gears can be classified into four types. One is spur gears, helical gears, herringbone gears, rack and pinion. And the intersecting axis gears can classify into two types. One is straight bevel gears, second one spiral bevel gears. And this non-parallel and non-intersecting axis gears are hypoid gears, worm and worm wheel, and spiral gears. Spur gears have teeth parallel to the axis of rotation and are used for transmitting motion between two parallel shafts. So as shown in the figure, the gears have mating to transmit the power between two parallel axis shafts. The spur gears are in simple construction, easy to manufacture and less costly, and they have a highest efficiency and excellent precision rating. So they are used in high speed and high load applications in all types of gear trains, in automobile and some machine tools, etc. etc. So the spur gears having a straight teeth on the contacting surfaces. So when they are in mating, the gears rotate in opposite direction and with different speeds depends on the number of teeth on the surface. Helical gears have teeth inclined to the axis of rotation and are used for transmitting motion between two parallel shafts. So the helical gears operate smoother and quieter than the spur gears because of gradual engagement of teeth during meshing and increased contact ratio. For the same width, the teeth of helical gears are longer than spur gears. Hence, helical gears have greater load carrying capacity. So because of the smoother operation, the helical gears are preferred in high speed and high load applications such as turbines and heavy vehicles. Since the teeth are inclined to the axis of rotation, helical gears are subjected to the axial thrust loads and bending couples. Herringbone gears, also known as double helical gears, consists of teeth having a right and left-handed helix cut on the same blank. The drawback of the helical gears, that is the problem of axial thrust, is eliminated by herringbone gears. In herringbone, that is a double helical gears, have two axial thrusts oppose each other and nullify. Hence, the shaft is free from any axial force. Though the herringbone gears have high load carrying capacity, they are more costlier than single helical gear. The herringbone gears are limited to high load carrying capacity applications such as in cement mills and crushers. Rack is a segment of gear of infinite diameter. When a straight line gear called rack meshes with the circular wheel called pinion, then the combination so formed is called rack and pinion arrangement. Rack and pinion arrangement is used to convert the rotary motion into linear motion or into translatory motion or vice versa. The use of the rack and pinion can be found in lathes where rack gives motion to the saddle and it is perfectly used or as a steering system of an automobiles. Intersecting axis gears, that is bevel, straight and spiral bevel gears, are used to transmit power between two intersecting shafts. That is, intersecting means it can transmit the power between two shafts which are having axis intersects with each other. Okay, and that the bevel gears are formed by cutting teeth along the elements of frustum of cone. The bevel gears are mounted on intersecting shaft at any angle, although 90-degree the shaft angle is most common. The two types of bevel gears, one is a straight bevel gear, another one is spiral bevel gears. If the teeth on the bevel gears are parallel to the lines generating the pitch cone, then they are called straight bevel gears. That is shown in the figure, first figure. Usually the straight bevel gears are used to connect at right angles which run at low speeds. When two straight bevel gears of the same size connect two shafts at right angles to each other, then the gears are called meter gears. Okay, clear? The meter gears are two straight bevel gears are of same size, connects two shafts at right angles. Okay, and then the straight bevel gears can operate under high speeds and high loads. These gears are noisier in operation at higher pitch line velocities. So these bevel gears can be found in automobile differentials, blenders and conveyors. Coming to the spiral bevel gears, the teeth of bevel gears are inclined at an angle to the face of the bevel. They are known as spiral bevel gears, that is shown in the second figure. Because of the spiral tooth, the contact length and the contact ratio are more in the spiral bevel gears. They are smoother in action and quieter than the straight tooth bevels. As there is a gradual load application and low impact stresses. The efficiency is slightly lower than the straight bevel gears. The spiral bevel gears find in applications to drive the differential of an automobile. Next, non-parallel and non-intersecting axis gears, that is hypoid, worm and worm wheel and spiral gears. So the skypoid gears are used for right angle in which the axes do not intersect. These gears are called hypoid gears because of their pitch surfaces are hyperboloids of the revolutions. They operate more smoothly and quietly than spiral bevel gears. And worm and worm wheel, also known as worm gears, are used to transmit power from one shaft to another shaft, which are non-intersecting and their axes are normally right angles to each other. The worm and worm gear pair consists of worm, which is very similar to screw, and worm gear, which is a helical gear as shown. The worm gears can be used for high speed reductions up to 400:1. The operation is smooth and quiet. Comparing between the bevel gears, the efficiency is low and they are very costlier. Worm gear drives are widely used as a speed reducer in material handling equipments, machine tools, and automobiles. The spiral gears, also known as crossed helical gears, SQ gears, are used in transmit power between two non-intersecting parallel shafts. The teeth of crossed helical gears have a pinion or the point of contact with each other. Therefore, they are used for light load and low load applications. That is machine tools, car, shaft and oil pumps on small IC engines, feed mechanisms, etc. And next important topic, terminology used in gears. That is nothing but nomenclature of spur gear. The various terms used in the study of gears, that is called gear nomenclatures. These terms are specific to spur gears and they are basic to all types of gears. First one, pitch surface. Pitch surface is the surface of the imaginary rolling cylinder that replaces the toothed gear. Second one, pitch point. The pitch point is the point on line joining centers of two mating gears at which the two pitch circles meet. Second one, pitch point. Then third one, pitch circle. The pitch circle is an imaginary circle of gear by which pure rolling action would give the same motion as the actual gear. And next one, circular pitch. Circular pitch is the distance measured along the circumference of the pitch circle from a point on one tooth to the corresponding on the adjacent tooth. And important one is module. The module is defined as the ratio of pitch circle diameter to the number of teeth on the gear. So the module is the index of the tooth size. The customary unit of module is millimeter per tooth. The standard module as per Bureau of Indian Standards, for which cutters are readily available in the market. So by with the use of this module, we can design the gears with specific number of teeth and the size. Effect of module on tooth size is as the module increases, the size of the gear tooth increases. The approximate tooth size for a few standard modules of choice 1 is having a specific size of a or increased in size of a tooth. Topland. Next term is topland. Topland is the surface of the top of the tooth. Next one, face of the tooth is the working surface of tooth profile lying above the pitch circle. And fillet. The fillet is the curved portion of the tooth flank at the root circle. Next one, addendum. So addendum is the radial distance of a tooth from the pitch circle to the top of the tooth. Next one, dedendum. Dedendum is the radial distance of a tooth from the pitch circle to the bottom of the tooth. Next one, clearance. Clearance is the difference between the dedendum of one gear and the addendum of the mating gear. Total depth. Total depth is the radial distance between the addendum and the dedendum of a gear. And the working depth is the radial distance from the addendum of circle to the clearance circle. Next, tooth thickness is also known as circular thickness, is the width of the tooth measured along the pitch circle. Next one, pressure angle or angle of obliquity. It's a very important terms used in the gears. The pressure angle is the angle between the common normal to two gears teeth at the point of contact and the common tangent at the pitch point. The standard pressure angles used are 14.5 degrees, 20 degrees and 25 degrees. The effect of pressure angle on gears will be discussed as per the standard size and standard modules which will be used in the applications. Next one, arc of contact. Arc of contact is the path traced by a point on the pitch circle from the beginning to the end of the engagement of the given pair of teeth. And the last term, that is velocity ratio. Velocity ratio is the ratio of speed of driving gear to the speed of driven gear. And the gear ratio is the number of teeth on the pinion to the number of teeth on the gear wheel. So these are some important terms used in gears. I hope you all understand about basics of gears and the terms used in gears. Okay, so thank you friends. See you with a new topic. Okay, bye bye.